Hello and welcome to our next lesson in this topic. We've been looking at light. Previously we've looked at how light is a transverse wave and we've spoken about the properties of transverse waves. We've said that light travels in straight lines only, and last lesson we looked at reflection and how that the angle of incidence always equals the angle of reflection. So today we need to look at refraction. So as you would do for any other lesson, I would like you to write the title, please, Refraction, at the top of the page in your exercise book. By the end of the lesson, you should be able to describe what happens when light is refracted. You should be able to explain why light is refracted, and you should be able to explain what happens to light when it travels through a lens. So first things first, and we need to keep this in mind throughout this lesson, okay? So I'm going to put it in red because it's really important. Light travels in straight lines. And I'm just going to neaten that up. Travels in straight lines. Always keep this in mind, okay? Light does not travel in a straight line. It only travels in straight lines unless something happens to it. So what I would like you to do, I would like you please to have a look at this image that is on the PowerPoint, but because I'm using Google Slides, I have to put it on the board like this. I'd like you to have a think about why this pencil appears to be bent. If you put a pencil or another object in a cup of water and you look down at it, it appears that the pencil is bent. However, once you take it out, it's not. It's the same as if you're at a swimming baths. If you're at the swimming baths and there's a person standing in the water, you're outside the pool looking down on them, their legs appear to be separate from their body, or they may appear to be bent or shorter than they actually are. We need to think about why this is the case. Now, the light that is allowing us to see this pencil is travelling from the air into the water, out of the water, and back into our eyes. So we can say that the light that allows us to see the pencil travels from air into water and into air again before entering our eyes. So it says light that allows us to see the pencil travels from the air into water and into the air again before entering our eyes. Now, the reason the pencil looks bent, or the reason that the pencil is not the shape we would expect it to be, is because of something called refraction. Refraction. Okay? So our first key word today is the word refraction. I'll change this to green. Refraction. R-E-F-R-A-C-T-I-O-N. Now, we can define refraction as the change in direction, of a ray or wave as a result of its change in speed. of its change in speed. So refraction is the change in direction of a ray or wave as a result of its change in speed. If we wanted to put that in plain English, refraction causes light to bend. When light bends as it moves from one medium to another. So we're going to add underneath here, but yeah, we'll use that colour. We can say, in fact, we won't put it that far, we'll just put it down a little bit, that refraction is the bending of light as it moves from one medium to another. Now, we've come across this word medium before, but just to refresh your memory, so let's have it as another keyword. A medium is either a solid, a liquid, or a gas. So solid, liquid, or gas. Okay? So when light travels from one medium to another, it is bent. Okay? So I want you to imagine that we've got our light source up in the sky, which is giving off rays of light. We've got our cup, which contains water and a pencil. So this is our cup, and inside the cup we've got a pencil, which I will put in red. I'm going to just make that a bit shorter so that we can fit everything on, if I can find the rubber. Oh, there it is. So we just want that a bit shorter down so that the light rays will look correct. So we've got our pencil, which is sort of appearing, well, it is straight, so we are going to draw it straight. We've got water inside the cup, as I said. Okay. So the light rays, and we need to draw someone's eye. Forgot about that. When we draw an eye, we sort of draw it like this. So that's an eye. We've got the cup with pencil. And we've got the light source. So the rays of light are moving down into the pencil, and it's bouncing or reflecting off the pencil. Now, rather than coming off in one continuous straight line, what will happen is at this point, it slows down and the light bends. Our area of refraction would be here, when the light moves from a liquid into a solid, when it changes mediums. So we can say that refraction of light, remember, it's bending. So the light is bending as it moves from one medium to another. So refraction of light happens as light moves from water to air. Okay? So we've said light travels in straight lines. However, sometimes we get refraction happens, which is where light bends as it moves from one medium to another due to its change in speed. So due to its change in speed, it appears to bend. A medium is a solid, liquid, or gas. So as the light enters the water, it is bent. It reflects off the pencil. And then when it leaves the water again, it is refracted. So if we were to do this correctly, you would also get refraction here. If you haven't got all these notes, pause the video so you can get them written down. And I've got a better image, which is on the PowerPoint, which explains refraction. So I did say at the start of the lesson that sometimes if you stand above a swimming pool, you notice that your friend's legs don't appear to be part of them. Yeah, it's a weird phenomenon. It just looks odd. On the PowerPoint, there's a diagram that looks like this, and I'm going to make it a bit bigger. This is a much better diagram than the one I've just drawn to explain how refraction happens. So as you can see, the real object is there, and the light is moving through the water before bending when it moves into the air. So again, our point of refraction would be here. So these are our points of refraction. This is where the light bends as it moves from water into the air. So I'm going to add another arrow here and say the light bends as it moves from water into air. Okay? Now, the man's brain can't make sense of this. It can't make sense of the light being bent. So his brain sees the object, knowing that light travels straight, as being shallower than it actually is. So we can add here that the man's brain can't make sense of the light bending so the object appears shallower. Okay? So because this light bends as it moves from one medium into another, because it's refracted, the man's brain can't make sense of this. So the object seems shallower than it actually is, because his brain thinks that the light is travelling in straight lines. So if we just rub this off so that you can see it a bit better. So if I just, if I get the rubber, is it just going to cover it in white? Yeah, it is. So if I refresh the screen and add the image in again, if we have a look at this image without my annotations, if you still want the annotations, you can go back and pause the video. If we have a look, this is where our refraction is happening. So the refraction is happening here and here. Okay, as the light moves from the water into the air, it bends. However, the man's brain can't make sense of that. His brain thinks that the light must have travelled in straight lines. Therefore, the object must be shallower than it actually is, because light can't bend. Therefore, if it's travelling in a straight line, it must be about there. So that is the apparent depth as he looks from the top of the water, but its actual depth is here because his brain can't take into account refraction. So if we have a look back to our learning objectives, you should be able to tell me what happens when light is refracted. You should be able to say that this is when light bends as it moves from one medium to another. Our next learning objective says, can you explain why light is refracted? So if we can just clear our board, if we can make everything black again, because that's not black, that's blue. Make everything black again so that it's easy to see what I'm writing. And we can put the subheading, why does light change direction? So why does light change direction? And we can put in brackets refraction. So why does refraction take place? And we can underline it, and I'm doing my best. There we go, that's pretty good. So to help us think about this, I've got some more images. Again, all these images are found on the PowerPoint, which I have added to the Google Classrooms. Now, we said in our definition that light is refracted due to a change in speed. So we can put, first of all in red, that light is refracted due to a change in speed. Okay? So I want you to imagine that there's a truck driving along a normal road surface. This truck is moving fast on the normal tarmac. However, once it hits the mud, the wheels on the truck are going to turn more slowly. Now, because this mud patch is at an angle, what's going to happen is that this part of the wheel is going to hit first. And that's going to go much slower than the outer wheels. That's going to cause the car or the truck to turn this way because its outer wheels will go faster. So its inner wheels are going to go slower and its outer wheels are going to continue to go fast. That's going to bend the car that way. However, once it then goes from the mud to the road again, the first wheels to hit the road, which are these ones, these are going to go faster. And that's going to cause the car to turn back the other way. So we can say that the wheels on a truck are slowed down by the mud, full stop. We can then say that wheels on one side of the truck hit the mud first. So wheels on the one side of the truck hit the mud first, causing it to turn. It to turn. Full stop. And we can then say, after the mud, comma, wheels that hit the road first road, hit the road first, speed back up. So when this car is travelling towards the mud, the wheels on this side, which hit the mud first, slow down, but the outer wheels remain fast. That causes the car to tilt and turn this way, turn downwards. As it drives down here, these wheels hit the tarmac first, causing them to speed up faster than these ones, bending the car back round to its normal speed. Now, as light travels through a block, a glass block, the same thing happens. The light slows down as it goes into the glass block and it bends inwards, and then when it leaves the glass block, it reflects back out. So we've got these light rays hitting the glass block, being slowed down and bending, and then speeding back up as they leave. So we can say that when light travels from air, which is a gas, through a glass block, which is a solid, it slows down. Causing it to bend. Causing it to bend. Okay? And we can then say that the light then speeds up as it leaves the glass block. Causing it to bend again. Causing it to bend again. A lot of writing there. So if you look at this, we could say that our glass block is probably, in fact, I might get all fancy and use a shape. What shapes we got? Where's the shapes? I've never done this before. Oh, no, we don't want that. Shall we get fancy? Shall we do a shape? That looks like a shape. We want to draw a square. We want our square to be like that. Okay, so that's our glass block. On the outside of the glass block, we've got air. Oh, no, we don't want that. We've got air. Go back to our pen. Yes, we know. Oh no, what have I done? It's okay, we'll sort it. So I want to take that off, turn that off, that's it. So oh no, where's my box gone? There it is. So we're going from air into a solid. Okay? So the light hits the solid and slows down, exactly like our wheels in the mud. The light hits the solid, slows down and bends. When it then leaves the solid, it speeds up and returns back to its original speed, back to its original angle. So we can add here that the light slows down. So the light slows down as it moves from the liquid into the solid, and then the light speeds up as it moves from the solid into the air again, into the gas. So refraction is caused, the bending of light is caused by light slowing down and speeding up as it moves from one medium to another. So what I'm going to do is I'm going to write that down somewhere. So we've got red, haven't we? We can say refraction is caused by light changing speed as it moves from one medium to another. So refraction is caused by light changing speed as it moves from one medium to another. So if you get asked, why does light change direction? There is your answer. So if we have a look back to our learning objectives, it says, can you explain why light is refracted? You should be able to do that now. Our final one, can you explain what happens to light when it travels through a lens? So let's clear our screen. Let's reset it back to black. Remember, if you haven't finished, you can pause the video at any point and revisit any parts if you're not sure. You can also pause the video and go on the internet and research further into things. In fact, I encourage you to do that. So we can put the subheading, what does a lens do? Does a lens do? Now, these are very, very useful to us. A lens is a piece of glass that refracts light. So a lens is defined as a piece of transparent material that refracts light. Refracts light. So a lens is a piece of transparent material that refracts light. An example of a lens, which I've got on my face right now, are glasses. Glasses can refract light so that we can see objects better. So we can put here, e.g., glasses refract light to improve vision. To improve vision. Okay? And I've got a diagram here which we can add. It is, again, on the PowerPoint. And it looks like this. It's quite a complicated diagram. However, we're going to have a go at explaining it and see if we can understand it. So, first of all, we've got what's known as a focal point. A focal point, which is shown here as F, is an area where light rays join. So, a focal point is an area where light rays meet. Now, a lens can either cause light rays to converge, where they come together to make a focal point. So we can say that lenses can cause light rays to converge, and I'm going to put that in a different color so it stands out, to converge, that's C-O-N-V-E-R-G-E. They can cause light rays to converge and meet at a focal point by coming together or lenses can cause them to diverge, which means the light rays move away from each other. That's not shown on here. However, we would say that these light rays are diverging. They're moving away from each other as they move away from the focal point. So the final thing we can say is that lenses can cause light rays to diverge. I'm going to put that in red. To diverge. Which means they move away from each other. So lenses are a piece of transparent material that refract light. For example, glasses refract light to improve your vision. When light is refracted, it can create a focal point, which is an area where light meets. So if we look, our focal point on this diagram would be here. That's the focal point. The light rays are coming together. These light rays are said to be converging. They are getting closer to each other as they move. So these are converging into a focal point. So these are converging. Whereas on the other hand, these light rays over here are diverging. They are moving further away. So these are diverging. Right then. So you should now be able to tell me what happens when light is refracted. You should be able to explain why light is refracted, and you should be able to explain what happens to light when it travels through a lens. If at any point in this lesson there is something you haven't got, please feel free to rewind it. Please feel free to go on the internet and see if you can find any extra information. This is not a test. It's just to help you understand these topics. So what we're going to do now, I'm going to change this screen. I want you, please, to pause the video, and I want you to have a go at the questions on the board at the moment. For the first one, you need to copy out the sentences and leave in the correct word. So one of these words is wrong. You want to leave that out and write out the sentences correctly. For question 2 and 3, you need to write out the question in your book before answering it. I would like you to pause the video now and have a go at those questions, please. Make sure you've got a different coloured pen to hand, preferably a green one, but if not, it doesn't matter. And then start the video when you're ready and we can mark and correct your work together. So pause the video now and get a different coloured pen ready to mark and correct your work. Okay, so you should have had a go at those questions by now. You should have a different coloured pen to hand so that we can start marking them. So we need to add an image. We need to add the first questions. We can make it a bit bigger. So question 1, you needed to leave the correct word in place. So I'm going to get a red pen. You need to correct your answers if you get them wrong. So it should read, when you look at a rock in the bottom of a swimming pool, it appears above where it actually is. That is because light refracts when it travels from water into air. It bends away from the normal as it goes into the air. This is because it speeds up. So it should have read, when you look at a rock in the bottom of a swimming pool, it appears above where it actually is. That is because the light refracts when it travels from water into air. It bends away from the normal as it goes into the air. This is because it speeds up. So let's add the final two questions. I'm going to make these a bit smaller. In fact, I might just keep it like that and put it up here. So, question 2A. Question 2A. So, we're going to do 2A. It says, explain what would happen to the speed and direction of water waves if they went straight into the area of shallow water rather than at an angle. So the speed would decrease. So speed would decrease. So the speed would decrease and the direction would remain the same. So direction would remain the same. So 2 marks for 2A. The speed would decrease because it's going from deeper water to shallow, but the direction would remain the same because it's doing it at the same angle. The speed and direction of light waves if they went straight into a glass block rather than at an angle. So 2B. So rather than the light going at an angle, it's going straight. So the speed would decrease, but the direction would stay the same. So the speed would decrease, but the angle or direction would remain the same. Okay? So for 2 marks for 2A, you should have said the speed would decrease and the direction would remain the same. And for 2B, the speed would decrease and the direction would remain the same. Next one, describe in detail how you could use the idea of a marching soldier to make a model of light refracting as it goes through a glass block. So you would need to draw a line. So number 3, for 1 mark, draw a line on the ground that represents the air/solid boundary. Okay, so you would need to draw a line that shows where they're going from the air into the glass. You would also need to draw another line. Draw another line that represents the solid air boundary. So what we mean by this is if you had a marching soldier, who's I'm going to draw as a stick man, you would need to draw some lines on the floor that show this is the solid and this is the air. So this would be the air, this would be the glass, and this would be the air again. So for 1 mark, you'd need to draw a line here to show where the air and glass is separate. And for another mark, you'd need to draw another line to show where the glass and air is separate. You would make lines of people a meter apart. Oh, I need to turn back to red, don't I? So, make lines of people 1 meter apart. And as they march towards the line, they need to be at an angle. So the people marching towards the line would need to come from this sort of direction. Okay? So for our next mark, we needed to say that the soldiers march to the line at an angle. Okay? When they pass the line, they would need to slow down. So the people who reach it first slow down and they turn into the glass. So we can put in the glass or in the lines, soldiers slow down and turn. So rather than being at this angle and continuing at that angle, what the soldiers would do is they would slow down and turn that way. We can then say that once they cross the second line, they speed up and move into the original angle. So after the second line, the soldiers, if I spelled soldiers right, the soldiers speed up and return to original direction. To the original direction. Okay? So the light would then go at that angle again. And that would show refraction. So for question 3, you need to draw a line on the ground that represents from air to glass, another line on the ground that represents from glass to air. You would have lines of people or soldiers about 1 meter apart. They would march towards the first line at an angle. They would then slow down and turn as they move into the glass, and they would then speed up and turn again as they leave back into the air. This demonstrates refraction. So we've gone over a lot today. If you have any questions at all about this lesson, please drop a comment in the Google Classrooms or send me an email and I will get back to you as soon as I possibly can. I will see you next lesson. Take care.